తెలుసది. హ్మ్. Good evening, students. Next problem is next problem. Write down. Given f of z is equal to u plus iv is an analytic function. Given f of z is equal to u plus iv is an analytic function. If the real part is given by, remember, real part of the analytic function is denoted by u. Imaginary part of the analytic function denoted by v. If the real part is given by u is equal to x cube minus 3xy square plus 3x square minus 3y square plus 1. Then find f of z. Similar procedure, the way we solved yesterday, in the same manner we need to solve. What is the procedure we did yesterday? First of all, you need to write f dash of z. Same procedure. First, we need to write f dash of z. F dash of z is equal to ux plus I into vx. But one thing, we are given only u. So we are able to find dou u by dou x, dou u by dou y. We are not given v. So we cannot find dou v by dou x. That's why write to dou v by dou x value in terms of u using CR equations. F dash of z is equal to dou u by dou x. Vx is minus I into uy. By CR equations. CR equations are dou u by dou x is equal to dou v by dou y. Dou u by dou y is equal to minus dou v by dou x. Substitute dou u by dou x and dou u by dou y values here. F dash of z is equal to dou u by dou x. Dou u by dou x is 3x square minus 3y square plus 6x. This is a dou u by dou x minus I into, what is dou u by dou y? minus 3x into y square derivative 2y minus 3x into 2y minus 6xy minus 3y square derivative with respect to y partially minus 6y. Remember, dou u by dou x means u derivative with respect to x partially. Dou u by dou y is u derivative with respect to y partially. Going to the next slide. Next slide. Taking x is equal to z and y is equal to 0. Substitute x is equal to z and y is equal to 0. Look there. If you take y is equal to 0, this term will be 0. If you take y is equal to 0, this term will be 0. And y is equal to 0, this term will be 0. So substitute x is equal to z. Then it is 3z square plus 6z. Remaining terms are zeros. F dash of z will be 3z square plus 6z. To get f of z, integrate both sides. Integral f dash of z dz is equal to integral 3z square plus 6z dz. Integral f dash of z is f of z. 3z square integration 3z cube by 3. So that is z cube. 6z integration 6z square by 2. That is 3z square. Integration completed. Add some constant c. Now, in this similar manner, try these problems. Next problem, next slide. Next slide. Given and note this, try yourself. F of z is equal to u plus iv is an analytic function. See, this is 57 slide yesterday's. This is 58 slide, 57 slide yesterday. 58 today's class. Is an analytic function. Problem number 1, if u is equal to xy, then f of z is iz square by 2 plus ic z square by 2 plus c minus iz square by 2 plus ic. Remember, constant can be written as either c or ic, no issue. Minus z square by 2 plus c. Here, the correct answer is option C. Remember, after completion of the integration, you can add the constant as either C or IC because it is a complex variable. So the constant should also be written as either C or IC. Similarly, next problem. If u of x comma y is equal to ax plus by, ax plus by, then f of z is, I will write in the next slide. Next slide. Option A minus IB into Z plus IC, A plus IB into Z minus IC, B minus IA into Z minus IC, B minus IA into Z plus IC. Try yourself. This is also similar to the previous problem answer. Very good. Option A. Similar to the previous problem answer, option A. And moreover, if do this problem also, if u is equal to e to the power of y sin x, then f of z is, then f of z is option A, I e to the power of iz plus ic, option B, e power minus iz plus c, option C, I e power minus iz plus ic, option D, minus I e power minus iz plus ic. After completion of the integration, the constant which we are adding should be either C or IC. You can add the arbitrary constant as C or IC. No issues regarding that. Try later. We'll go to the next model. Option C. Correct. AX plus BY. AX plus BY will not be. F of Z is analytic. I said polynomial is analytic means complex number. Z power non-negative integer is a complex polynomial. Z power non-negative integer is a complex polynomial. That complex polynomial is analytic. Real polynomial need not be analytic. Real polynomial need not be analytic. Now, model number 2. Model number 2. Model number 2. Construction of analytic function. Model number 1 is u is given. Instead of finding v directly, we found f of z is equal to u plus iv. Are v given without finding u? Directly we found f of z is equal to u plus iv in terms of z. Remember everyone, model number 2. Model number 2 is important and expected. Model number 2 is very, very important and expected model for exam point of view. Given f of z is equal to, note down, given f of z is equal to u plus iv is an analytic function. Suppose the real part, if the real part u is given, then to find the imaginary part v, we proceed as follows. Suppose you are given the real part u, then to find the imaginary part v. Are v given, then to find the real part u. This is model number 2 regarding construction of analytic function. Remember, you are given u, you are asked to find v. You are given u, you are asked to find v. So we need to use the definition of total derivative of v. To find v, we need to use the definition of total derivative of v. By the definition of total derivative of v. By the definition of total derivative of v, we have total derivative of v definition, dv is equal to dou v by dou x dx. dv is equal to dou v by dou x dx plus dou v by dou y dy. Remember everyone, you are given u, you are asked to find v. So we need to use the definition of total derivative of v. That is dv is equal to del v by del x dx plus del v by del y dy. But you are given u, so you are able to find del u by del x, del u by del y. You cannot find del v by del x, del v by del y because you are not given v. That's why write to del v by del x and del v by del y in terms of u. By CR equations, del v by del x short form vx, del v by del y short form vy. CR equations, ux is equal to vy, uy is equal to minus vx. Multiply both sides of this last equation by minus symbol. Then it is minus into uy is equal to minus into minus plus. That is plus vx. Now remember that dv is equal to vx. What is vx value? Vx value minus uy dx plus, and observe this Vy. What is Vy? Vy value ux. Vy value ux dy. So this is dv. Now integrating both sides. Integrate both sides. Actually, to get v, we simply integrate both sides in order to get v value. So integral dv is equal to integral minus uy dx plus integral ux dy. Integral dv is v. V is equal to integral minus dou u by dou y dx. Everyone should remember, when you are integrating minus del u by del y with respect to x, assume all y terms as constants. Assume all y terms as constants. From minus del u by del y, assume y terms as constants. Plus, when you are integrating with respect to y, then you need to consider the terms. You need to consider the terms of dou u by dou x, which do not contain x, dy. Remember everyone, when you are integrating with respect to x, assume all y terms as constants. When you are integrating with respect to y, all terms of dou u by dou x must be the terms which do not contain, all the terms which do not contain x terms from dou u by dou x should be considered. You write to dou u by dou x. In that dou u by dou x, what are the terms where x is not at all involved? Only those terms are to be written in this bracket. Those terms are to be integrated with respect to y. Next line. Remember this. Technique of solving the, don't remember the formula. Technique of solving the problem you remember. Suppose you are given u. If you are given u, similar to exact differential equation only, you are given u. To find v, use a total derivative of v definition. That is dv is equal to dou v by dou x dx plus dou v by dou y dy. Suppose v is given, then to find u, du is equal to dou u by dou x dx plus dou u by dou y dy, and then integrate both sides. And then integrate both sides. Next line. Similarly, u. Similarly, u can be determined if the imaginary part v is given. Suppose imaginary part v is given, then we can do the problems in the same manner. Now we do problems. This is very, very important and expected model. How can you apply Milne-Thomson method? Milne-Thomson method, if you want, you can apply. And again, Substitute x is equal to z and y is equal to 0. Then you will get the answer. When you apply Millie-Thomson method, you will get the answer in terms of z. But here we are writing u value or v value in terms of x. If you want, you can apply your Millie-Thomson method and at the same time substitute z is equal to x plus iy. Then only you will get the answer in terms of x and y. U given, we are finding v in terms of xy. In final answer, substituting z is equal to x plus iy will consume your lot of valuable time. If you want, you can apply, no issue. Still some students continuously mailing. I have to teach or I have to check your question and answers. You have lot of questions than listening to the class. Notes will be uploaded. You must have patience. Only one day is completed. Please cooperate. Notes will be uploaded. Why you are worrying, I don't know. Write down problem number 1. A harmonic function is analytic. A harmonic function is analytic if it satisfies the Laplace equation. If u of xy is equal to 2x square minus 2y square plus 4xy is a harmonic function, then its conjugate harmonic function v of xy is option A 4xy minus 2x square plus 2y square plus constant. Option B. I will write in the next slide. Option B. Four y square minus 4xy plus constant. Option C. 2x square minus 2y square plus 4xy plus constant. Option D. Sorry, this is only xy. Option D minus 4xy plus 2y square minus 2x square Listen to me. If you want, you can verify from the options. Listen to me. If more than one option will satisfy Cauchy-Riemann equation, simply verify Cauchy-Riemann equations. You are given U. You are given U among four options. You are asked to identify what is V. So first assume option A as V and cross check whether it is satisfying CR equations or not. Suppose if it satisfies option A satisfying CR equations with U, then option A is the right answer. You can simply cross check with options also by checking options. Anyhow, I will teach as per the procedure and cross check in the exam with the help of options. I will let you know with the help of options also. Given why some students continuously raising or not, I don't know. I will stop the class. Please cancel that and sit. Otherwise, I'll stop the class. Please disable that option. Otherwise, from my side, I permanently disable. At the end of the class also, no doubts. Unnecessarily, please raise. Given u of xy is equal to given u of xy is equal to 2x square minus some students wantedly they want to cheat by raising, still raising. I will disable permanently. That is better. Otherwise, you will never listen. Again raising. Okay. I am disabling permanently. Mr. Venkat Krishna, please tell me what's your problem. I'll stop the class and talk to you. Unnecessarily raising the hands, no. I'll stop the class and talk to everybody. Tell me, Mr. Mano Sharath. You have paid the fee and sitting in front of the computer or your mobile phone for long hours. Unnecessarily disturbed, that's your problem. The class becoming delayed. You don't have enough time for exam. You remember it's already September. Okay. So find dou u by dou x. Please leave that. Find dou u by dou x is equal to 4x plus 4y and dou u by dou y is equal to minus 2 into 2y. Minus 2 into 2y minus 4y. 4xy derivative with respect to y partially, that is 4x. You are given u. You are asked to find v. So use the definition of total derivative of v. That is dv is equal to dou v by dou x dx. Dou v by dou y short form v suffix y dy. Now, according to CR equations, ux is equal to vy and uy is equal to minus vx. Multiply both sides of this last equation by minus symbol. Then it is minus into uy is equal to minus into minus plus vx. Now, dv is equal to vx. We are given only v. We are given only u. We are not given v. So we cannot find vx and vy. That's why you need to write vx and vy in terms of u using CR equations. According to CR equations, Vx is minus Uy dx, Vy is Ux and dy. CR equations. So substitute there. I'm going to the next slide. dv is equal to minus dou u by dou y. Minus into dou u by dou y, that is minus 4y plus 4x dx plus ux. Ux means 4x plus 4y. Ux means 4x plus 4y dy. To get v, simply integrate both sides. Integral dv is equal to integral, take minus symbol into the bracket, minus into minus 4y plus 4y, minus into plus 4x minus 4x dx, plus integral 4x plus 4y dy. So what I said, when you are integrating with respect to x, when you are integrating with respect to x, assume y constant. And when you are integrating with respect to y, choose the terms which do not contain x. Choose terms which do not contain x. Integral dv is v, integral 4y dx, 4y constant, integral dx is x. Integral 4x dx, 4x square by 2, 2x square. So from the second bracket, you need to consider the term where x is not at all involved. So that is only 4y. Integral 4y dy, 4y square by 2, that is 2y square plus c. So option A is the right answer. Option A is the right answer. But my humble request to everybody, these types of problems, whenever you come across in the gate examination, you are given U. So consider the option functions as V. First to assume option A as V and verify CR equations. CR equations are satisfied, option A correct. Not satisfied, check the same story with option B, option C, option D as well. Suppose the given function is a complicated function in the options, finding derivative is complicated, then only you need to solve the problem as per the procedure in the examination. Otherwise, options will work better in order to get the answer easily and effectively so that we can manage the time also. Next, problem number 2. Note this. First problem given in the gate. It was given in the gate mechanical engineering 2019. Next, the function f of z of a complex variable z is equal to x plus iy where I is equal to root of minus 1 is given as listen to me. Some students have a cross checking why it is correct. Now just observe. This is V. Cross checking method also we can do. Just one minute. Let me write. F of z is equal to x cube minus 3xy square plus I into V of xy. Stop. For this function to be analytic, V of xy should be option A 3xy square minus y cube plus constant. Option B 3x square y square minus y cube constant. Option C x cube minus 3x square y constant. Option D 3x square y minus y cube plus constant. This problem given in the GATE Mechanical Engineering 2020 GATE. One problem we did as per the procedure. No. Now let us solve this problem with the help of options. Most of the students are answering correctly option D. That is fine. Correct. Let us check with the options. Remember, real part of the analytic function, let it be U. And each and every option, let it be V, and we proceed further. Next slide. Next slide. U, the real part of the analytic function, let it be U, x cube minus 3xy square. And V, what is V? Let us assume option A as V, 3xy square minus y cube. We are checking option A now. Option A, verify dou u by dou x value 3x square minus 3y square. Dou v by dou x value 3y square. That's it. Similarly, dou u by dou y value minus 3x into 2y minus 6xy. Dou v by dou y value 3x into 2y 6xy minus 3y square. Option A, CR equations are not satisfied. So option A is not correct. Option A not correct. CR equations not satisfied. So similarly, check with option B. assume option B function as V. Already ux uy we found. These are ux uy. Option B, let it be V. 3x square y square minus yq plus constant dou v by dou x. 3 into x square derivative 2x, 6x y square. Dou v by dou y. Y square derivative 2y. 2y into 3x square. 6x square y minus 3y square. Dou u by dou x value not equal to dou v by dou y. So option B not correct. CR equations will not be satisfied. Option B not correct. Check with option C also. Option D correct. Options method, some disadvantages are there. Suppose option D is correct, then you need to take much time. And moreover, suppose finding dou v by dou x, dou v by dou y is complicated, then options method will not work out. It is better to solve as per the procedure in that case. Now v is equal to x cube minus 3x square y. Of course, I know you people solved 3x square minus 6xy, dou v by dou y is minus 3x square. Even option C not correct. CR equations not satisfied. Option C not correct. CR equations not satisfied. Option D. Let it be V. V is equal to 3x square y minus y cube plus constant. Find dou v by dou x. 3x square derivative 6xy. That's it. Dou v by dou y. That is 3x square minus 3y square. CR equations are satisfied. Dou u by dou x is equal to dou v by dou y. Dou u by dou y is equal to minus dou v by dou x. CR equations are satisfied. Therefore, option D is correct. But options checking will have some disadvantages. Sometimes it is very, very lengthy to solve. Similarly, note this problem. An analytic function of a complex variable z is equal to x plus iy, where I is equal to root of minus 1, is defined as f of z is equal to x square minus y square plus I into psi of xy, where psi of x comma y is a real function. The value of imaginary the value of imaginary part of f of z at z is equal to 1 plus I is dash a round of two decimal places. Very simple. You are given the real part u. Psi of xy means imaginary part. Simply find imaginary part psi of xy. Psi of xy means v. Simply find the imaginary part v. Once we get the imaginary part v, you will get imaginary part v in terms of x and y. So then how to substitute z is equal to 1 plus I? 1 plus I is a complex number. Every complex number should also be represented by a point form. 1 plus I, real part x coordinate, imaginary part y coordinate. 1 plus I, real part 1, imaginary part 1. Once you get the imaginary part v of xy, you are substituting z is equal to 1 plus I means you are substituting x is equal to 1, y is equal to 1. Answer 2. Answer 2. This problem given in the gate mechanical engineering 2020. Answer 2. Gate key released answer is 1.99 to 2.01. Gate key released answer is 1.99 to 2.01. Similarly, note this and try. Let f of z is equal to u plus iv, where u is equal to 2x into 1 minus y. And then consider the following statements. Statement 1, S1. U is harmonic function. Statement 2. Statement 2. F of z is analytic and v is equal to 2y plus x square minus y square. Statement 3. F of z is equal to iz square plus 2z. Which of the following which of the following statements are true? Actually, these types of questions will be asked under MSQ, multiple select questions. For multiple select questions, one or more than one answers will be the right answers. Option A, S1 and S2 only. Option B, S2 and S3 only. Option C, S1 and S3 only. Option D, S1 comma S2 and S3. And now you are given f of z is equal to, this is the problem. Option D correct. Option D correct. Let me check and listen to me. You are given U. U is equal to 2x into 1 minus y. That is 2x minus 2xy. Option A, sorry, S1 is U is a harmonic function. U harmonic function means dou square U by dou x square plus dou square U by dou y square 0. That's why let us find dou U by dou x, short form Ux. 2x derivative with respect to x partially 2 minus 2xy derivative with respect to x partially 2y. This is dou U by dou x. Dou square U by dou x square means dou U by dou x derivative with respect to x partially. That is 2 derivative with respect to x partially 0. 2y derivative with respect to x partially 0. Dou square U by dou x square 0. Similarly, dou U by dou y. Dou U by dou y, 2x derivative with respect to y partially 0 minus 2xy derivative with respect to y partially minus 2x. Dou square U by dou y square means minus 2x derivative with respect to y partially 0, implies dou square U by dou x square plus dou square U by dou y square is equal to 0. Therefore, U is a harmonic function. Yesterday I gave the definition. Any function that satisfies Laplace equation, that is called harmonic function. U satisfies Laplace equation, so U is a harmonic function. Now let us find f of z. F of z is analytic and v is equal to 2y plus x square minus y square. Okay, let us see. Let us find v. If u is given, how to find v? By with the help of options also we can cross check. So f of z is analytic. To find v, now v is equal to dou v by dou x dx plus dou v by dou y dy. Dou v by dou x, that is minus dou u by dou y. Dou v by dou y, that is dou u by dou x. That is from CR equations. Now minus into dou u by dou y. Dou u by dou y is minus 2x. Minus into minus 2x plus 2x. Dou u by, sorry, this is dv. Dou u by dou x. Dou u by dou x is 2 minus 2y. Integrate both sides. Next slide. Next slide. Integral dv is equal to integral 2x dx plus integral 2 minus 2y dy. Integral dv is equal to v. Integral 2x dx x square plus, of course, when you are integrating with respect to x, assume y constant. When you are integrating with respect to y, consider the terms do not contain x. Consider the terms do not contain x. Integral dv is v. Integral 2x dx x square. Integral 2 dy, that is 2y. Integral 2y dy, that is y square. What is our v value? X square plus 2y minus y square. V value x square plus 2y minus y square. Fine. You are given u. Option A correct. Option B also correct. Look there. Option A correct. Option B correct. Now let us check. Sorry, S1 correct, S2 correct. Let us check S3 correct or wrong. Now f of z is equal to u plus iv. Don't find f of z in terms of z by using Milne-Thomson method. Directly we can write in this manner, f of z is equal to u plus iv. F of z is equal to, what is u? 2x minus 2xy. This is u plus I into, what is v? X square plus 2y minus y square. And all of you listen to me carefully. No need to simplify to make it as whatever in terms of z. Suppose you know u and v values, directly we can write z value. Suppose you know u and v values, directly we can write f of z in terms of z. Simply substitute x is equal to z, y is equal to 0. No need to find f of z in terms of z. If you know u and v, directly put x, z, y 0. If I take y is equal to 0, this is 0. Y is equal to 0, this is 0. Y is equal to 0, this is 0. And now f of z is equal to x value z. 2z plus I into x value z, iz square. 2z plus iz square. So option C also correct. S3 also correct. Option D correct. S3 also correct. Fz is equal to 2z plus iz square. 2z plus iz square. Remember, if any function is analytic, then its real and imaginary part by default analytic. That is true. By default, it is analytic. Now, one basic level question. Okay, we'll discuss at the end of the chapter. A basic level which we were given in the gate or volume 1 or volume 2 booklet problems. And now, next model, complex integration. Remember, in case anything is missed, that I can teach at the end of the chapter. I mean, from the basics, anything one or two questions only. If they missed from volume 1, I will teach at the end of the chapter. But don't worry, everything will be taught. Plus, few more problems other than volume 1 should also be taught. What is the definition of complex line integral? Remember, suppose f of z is a complex valued function, then the complex integral f of z dz is called complex line integral. Let f of z be let f of z be a complex valued function. Then the integral f of z dz is called a complex line integral. Remember, integral f of z dz. Integral f of z dz means, let us assume f of z is force, dz is displacement. F of z into dz means force into displacement. That is work done. Work done. Integration means what? Total work done. Then we are finding total work done by a force. Then we are finding the total work done by a force in displacing the particle along the curve C. Still, you are not able to understand the difference between model 1 and model 2. Model number 1 is f of z is equal to u plus iv is an analytic function. Suppose you are given the real part u without finding the imaginary part v separately, directly we can find f of z is equal to u plus iv value in terms of z. Suppose you are given v without finding u, directly we can find u plus iv in terms of z. That is model number 1. Model number 2 is f of z is equal to u plus iv is an analytic function. You are given the real part u only. By using the real part u, you need to find only imaginary part v in terms of x and y. Suppose you are given v, you need to find the real part u in terms of x and y. Whereas in the previous model, u given without finding v, directly we need to find u plus iv in terms of z. Still, you people have a doubt. Simply, you can forget model number 1 for exam point of view. All model number 1 problems can also be solved using model number 2. How can we? We are given f of z is equal to u plus iv is analytic function. You are given u. Find imaginary part v from model number 2 and then write f of z is equal to u plus iv and then substitute x is equal to z, y is equal to 0. You will get model number 2. Model number 1. From model number 2, we can find model number 1 also. Suppose f of z is equal to u plus iv. You are given v. Find only u using model number 2. Write f of z is equal to u plus iv. Substitute u and v. Substitute x is equal to z, y is equal to 0. That is model number 1. This is complex line integral. Now, definition. Simple closed curve. Remember, simple closed curve means any closed curve that does not intersect itself. One closed curve should not intersect itself is called a simple closed curve. A closed curve which does not intersect itself is called a simple closed curve. Every curve direction should always be anti-clockwise direction. This is a simple closed curve. One closed curve direction always anti-clockwise direction, because anti-clockwise direction is the positive direction, clockwise direction will be the negative direction. Any closed curve that doesn't intersect itself is a simple closed curve. These are the examples of simple closed curves. Now, this is not a simple closed curve. Direction always anti-clockwise direction. Please keep in the mind any closed curve which intersect itself is not a simple closed curve. And definition, simple connected region. So what do you mean by simple connected region? Closed curve means you can choose a plain sheet of the paper also. You take one closed curve, a closed curve that is shrinking. You take one closed curve, that closed curve that shrinks to a point. It has to sink to a point. Listen to me. Look there. This is a closed curve. Means you take one plain sheet of the paper and cut it like this. Suppose you are shrinking this region, the area inside this closed curve you shrink. Suppose this area is gradually shrinking, it gradually shrink, means contract. The area inside that closed curve is gradually shrinking, and finally after shrinking it becomes one point only. That is called a simple connected region. A closed curve that shrinks to a point, that is a simple connected region. If the area inside this closed curve, if you can shrink, that becomes one point. So it is a simple connected region. A closed curve which can be shrunk. A closed curve which can be shrunk. Shrunk means past tense or past participle of shrink. A closed curve which can be shrunk to a which can shrink to a point is called simple connected region. What is the best example for simple connected region? Plain sheet of the paper containing no holes on it. Any plain sheet of the paper doesn't have any hole on that. That is a simple connected region. What do you mean by multiple connected region? Plain sheet of the paper does not contain any hole on that. That is a simple connected region. Plain sheet of the paper containing some holes on it, that is not a simple connected region. This is the plain sheet of the paper containing some holes on it. These are the holes of the paper. First hole C1, second hole C2. Plain sheet of the paper containing some holes on that is not a simple connected region. Not a simple connected region is also called multiple connected region. These are the holes of the paper. Plain sheet of the paper containing some holes on that is a multiple connected region. That this big closed curve, let it be C, small closed curve, let it be C1, another small closed curve, let it be C2, another small closed curve, let it be C3, which are just like holes only. In the previous diagram, if you the area inside this closed curve, if you can shrink, gradually it is shrinking, finally it becomes one point. That is called simple connected region. But you cannot shrink this region. How can you shrink this? Inside some holes are there. You cannot shrink that. Therefore, this is not simple connected region. It is multiple connected region. Plain sheet of the paper containing some holes is called multiple connected region. Simple connected region means any visibility. See here, you take one plain sheet of the paper. You take one plain sheet of the paper and fold it like this. Fold it 1,000 times. After folding it 1,000 times, it becomes one point only. It becomes one point only. So any closed curve means one paper. When you fold that paper 1,000 times or 10,000 times, it becomes one point. If it becomes one point, that is a simple connected region. If it doesn't become a point after folding 1,000 times, 10,000 times, 20,000 times, it is not a simple connected region. That is multiple connected region because there are holes inside the paper. Because anti-clockwise direction is the positive direction, not only in mathematics. Any subject anywhere, as far as the direction is concerned, always consider positive direction means anti-clockwise direction. Example, this is a plain sheet of paper without holes is called simple connected region. A plain sheet of paper with holes is called multiple connected region. Next slide. Next, complex line integral. Complex line integral definition I gave already. Complex line integral. Look here, we have already written the definition, complex line integral. But here, what I want to say is, write down, consider the complex line integral, integral P to Q f of z dz. If you assume f of z is force, dz is displacement. So force into displacement is work done. Integration means total work done by a force. Integration means total work done by a force in displacing the particle. Total work done by a force. Integral P to Q f of z dz is a total work done by a force in displacing the particle along the specified path from P to Q. But from P to Q, we have infinite number of possible paths. From P to Q, this is one possible path. From P to Q, this is another possible path. From P to Q, this is another possible path. From P to Q, this is another possible path. From P to Q, we have infinite number of possible paths. Infinite number of possible paths. That is not the case here. What I want to say is, suppose f of z is analytic function. Suppose f of z is analytic function, then you need not integrate integral P to Q f of z dz. It is not required to integrate along the specified path from P to Q. Not required to integrate along the specified path from P to Q. On integrating f of z dz directly, whatever the answer you get, means on integrate, suppose f of z is z square. On integrating z square dz, whatever the answer you get, on integrating z square dz, whatever the answer you get, same answer only you get, even though it is integrated from P to Q along this path, along this path, along any path. From P to Q, infinite number of paths are there. Suppose f of z is analytic function, then on integrating f of z dz directly, whatever the answer you get, same answer only you get if it can be integrated along any path from P to Q. Infinite number of paths are there. You can integrate along all those infinite number of paths from P to Q, same answer we get. Suppose f of z is not analytic function, then we should not directly integrate this. We have to integrate along the specified path from P to Q only if it is not analytic. Write down. In the problems I will show you what does it mean. If f of z is analytic function, then integral P to Q not a closed line integral. Integral p to q f of z depends only on the endpoints, of the path, but not on the path. What does it mean? Its value depends upon the endpoints means. Its value depends upon the endpoints means integrate directly. Its value depends upon the path means you need to integrate along the specified path. Means in the exam they will mention the path equation along this path or along this path. Path equation will be mentioned and you need to integrate along that specified path. I will show you, yes, initial and final points. I will show in the problems how to do these two cases. Until then, wait for 5 minutes. If f of z is not analytic function, then the value of the integral depends on the path, but not on the endpoints. Means f of z is not analytic function, then you need to integrate along the path mentioned in the given problem. Don't worry, I'll show what I explained here. I'll show with an example. Problem number 1. Evaluate integral 0 to 1 plus I x square minus iy dz along a curve y is equal to x square. Now you need to remember, whenever you want to find the value of any given function along a curve and that curve is not a closed curve, if it is a closed curve, we need to use Cauchy's integral theorem or Cauchy's integral formula. That's why be careful what I'm saying. Whenever you want to solve any problem along a curve that is not a closed curve, then that problem should be solved in this manner in complex variables. Now, every complex number should also be represented by point form. Real part of the complex number is x coordinate, imaginary part of the complex number is y coordinate. So here lower limit of the integral is 0. 0 can be written as 0 plus I into 0. So real part 0, imaginary part 0. Upper limit of the integral is 1 plus I. Upper limit of the integral is 1 plus I. Real part 1, imaginary part 1. So 1 plus I, real part 1, imaginary part 1, 1 comma 1. X square minus Iy, let it be force, let it be displacement. Force into displacement, work done. Integration means total work done. So we need total work done by a force in displacing the particle along the specified path y is equal to x square along the specified path y is equal to x square from 0, 0 to 1, 1. First of all, the curve is not a closed curve. If the curve is not a closed curve, then you need to check whether integrand is analytic function or not. If it is not analytic, direct integration. If it is analytic, if it is not analytic, integrate along the specified path. If it is not analytic, if it is analytic, direct integration. Now assume the real part is u. It is not analytic. Real part is u and imaginary part is minus y. Find dou u by dou x, 2x. Dou u by dou y, 0. Similarly, find dou v by dou x, 0. Dou v by dou y, minus 1. CR equations not satisfied. Dou u by dou x value not equal to dou v by dou y. Don't worry, some students still enjoying by raising hands. After the class, after the break, I'll permanently disable. Dou u by dou x is not equal to dou v by dou y. Of course, dou u by dou y is equal to minus dou v by dou x. But one of the CR condition not satisfied. If CR equations not satisfied, it cannot be differentiable and hence it cannot be analytic as well. Therefore, f of z is not analytic. It is not differentiable, not analytic as well. Next slide. CR equations not satisfied. So f of z is not what I said. If it is not analytic function, then you need to integrate along the specified path. If it is not analytic, you need to integrate along the integration value depends upon the path. Integration value depends upon the path means you need to integrate along the specified path. What is the specified path? Y is equal to x square. Specified path is y is equal to x square. So dy is equal to 2x dx. We are integrating along y is equal to x square path. Now take the given problem. Given problem is integral 0 to 1 plus I x square minus iy dz. As you all people know, every complex number should also be written as point form. 0 can be written as 0 plus I into 0. So real part 0, imaginary part 0. Upper limit 1 plus I. Real part 1, imaginary part 1. X square minus iy z. Z value x plus iy. Z value x plus iy. So that dz is equal to dx plus, so that dz is equal to dx plus I dy. In place of this dz, I can write dx plus I dy. But what I said, integration value depends upon the path. What is the path equation? Y is equal to x square. Path equation is y is equal to x square. So you can substitute y is equal to x square, or you can substitute x is equal to root y. Choice is yours. I want to substitute y is equal to x square. I want to substitute y is equal to x square and dy. Here dy. Y is equal to x square, and this dy should be replaced by 2x dx. Now the entire problem has been converted in terms of x. So we just need x limits only. X limits 0 to 1. X limits 0 to 1. We just need x limits 0 to 1. X square common. So 1 minus I into x square. Here also dx common. Take it out. Then it would be 1 plus 2ix into dx. I will write in the next slide. First 1 minus I out. Next slide. Now integral 0 to 1. Take this x square into the bracket. X square into 1. X square into 2ix, that is 2ix cube dx. Now 1 minus I integral x square dx is x cube by 3 plus 2I into integral x cube dx is x power 4 by 4 between the limits 0 to 1. 2 ones, 2 twos. So 1 minus I into, replace x by upper limit 1, 1 by 3 plus I by 2 because x value 1. 1 minus I into, take LCM 6, 2 plus 3i. Now 1 into 2 plus 3i, that is 2 plus 3i, minus I into plus 2, that is minus 2i, minus I into plus 3i, that is minus 3i square by 6. I will write in the next slide, or I will write here itself. So this is equal to 3i minus 2i, that is I. Now I square value minus 1. Minus 1 into minus 3 plus 3 plus 3 plus 2, 5. 5 plus I by 6. Problem number 2. Problem number 2. Evaluate integral z dz along a curve C from the 5 plus I by 6. From the origin to 1 plus I, where C is y is equal to x. Problem number 2, C is y is equal to x square. Look there, y is equal to x square curve. This is y is equal to x square curve, and y is equal to x. This is y is equal to x. This is y is equal to x, and this is y is equal to x square curve. From the origin means 0 0. Do you know, I have drawn y is equal to x curve. I have also drawn y is equal to x square curve. Now y is equal to x curve and y is equal to x square curve intersecting here. So if I take y is equal to x here, y is equal to x and y is equal to x square. Left hand sides are same, so right sides will be same. Then 1x cancel, so that this point, intersection point x coordinate 1, intersection point x coordinate 1. If I take x coordinate 1, y coordinate also 1. This is y is equal to x square. And be careful what I'm saying, everyone. As we discussed already, what are the entire functions? Sin z, cos z, e power z, e power minus z, sin hz, cos hz, and polynomial. And polynomial. Polynomial means it is a complex polynomial. Complex polynomial means z power non-negative integer. Z power non-negative integer. Look here, it is integral z dz. It is z power non-negative integer. Non-negative integer is 1. Therefore, integral z dz, z is a polynomial. Z is a polynomial which is analytic everywhere, entire function. Yesterday I taught f of z is equal to z. Z power 1, z power any non-negative integer is a complex polynomial which is analytic everywhere. Is a polynomial. It is analytic everywhere. But what I said, suppose it is analytic everywhere, then you need not integrate along the specified path. If it is analytic function, on integrating your given problem directly, whatever the answer you get, same answer only you get. If it can be integrated along y is equal to x, or along y is equal to x square, along y is equal to x cube, along any path between 0 0 and 1 1. If it is analytic function, integrate it directly. Whatever the answer you get, same answer only you get if it is integrated along any path from origin to 1 plus I. Origin to 1 plus I. Origin means 0 0. Origin means 0 0. In complex form, it is only 0. Complex form only 0. And upper limit is 1 plus I. Upper limit is 1 plus I. If it is analytic function, integrate directly. If it is analytic function, integrate directly. No need to integrate along the specified path y is equal to x or y is equal to x square. Integrate directly, whatever the answer you get, same answer you get. If it can be integrated along y is equal to x in the similar manner of previous problem, or along y is equal to x square in the similar manner of previous problem, same answer you get. So, but no need to integrate 1 plus I whole square by 2. This is 1 square plus I square plus 2I by 2. I square value minus 1 plus 1 cancel. Still 2I by 2. 2I by 2, that is I. Problem number 3. Just 5 to 10 minutes I need. After that I will give you the break. Consider the line integral I is equal to integral x square plus iy square into dz, where z is equal to x plus iy, full stop. And the line capital C is shown in the figure below. Zero, zero, 1 comma 0, 1 comma I, and this is I. This is C. And we were asked to find the value of the integral along C. Along C. C is a straight line passing through the origin. Along C only we need. The value of capital I is option A 1 by 2 into I. Option B 2 by 3 into I. Option C 3 by 4 into I. Option D 4 by 5 into I. It was given in the gate electrical engineering 2017. In the solution, I will modify the diagram. I'll modify the diagram in the solution. Small modification. Given diagram correct only. For our convenience, we are modifying now in the solution. This is 0, 0. Again, raising hand. Okay, good. Wait for 5 minutes. After the break, I'll do that. Now, this is 1, comma 0. Actually, this point is 1, comma I. 1, comma I. This point. Be careful what I'm saying. This point is 1, comma I. Real part of the complex number is not there. 1, comma I. Real part not there. Imaginary part is 1. Every complex number should be written as point form. 1, comma I here. Look there. 1, comma I. Real part already is there. Imaginary part. I coefficient is 1. I coefficient is 1. Next here, I is there. Here I is there. Real part 0, imaginary part 1. Real part 0, imaginary part 1. Every complex number should also be represented by point form. Real part x coordinate, imaginary part y coordinate. Option B correct. Now assume the given function as f of z, x square plus I into y square. Real part let it be u. Imaginary part let it be v. So dou u by dou x is equal to 2x. Dou u by dou y is equal to 0. Dou v by dou x is equal to 0. Dou v by dou y is equal to 2y. Now dou u by dou x value not equal to dou v by dou y. Of course, dou u by dou y value not is equal to minus dou v by dou x. Be careful what I'm saying. We were asked to find the value of the integral. We were asked to find integration value along the curve C. Along the curve C. C is a straight line passing through the origin. C is a straight line passing through the origin. That is y is equal to mx. Y is equal to mx. Slope of the straight line is x1 y1 x2 y2. y2 minus y1 by x2 minus x1. That is slope of the straight line is x. We just need to find the value of the integral along the straight line passing through the origin, that is C, that is along y is equal to x. So therefore you need to cross check whether your function is analytic or not along y is equal to x. You need to check whether your answer is analytic or not along y is equal to x. We are checking along y is equal to x only because we were asked to find along C, means along y is equal to x. So along y is equal to x, dou u by dou x is 2x, dou u by dou y is 0, dou v by dou x is 0, dou v by dou y is 2x. If I take y is equal to x now, CR equations are satisfied. If I take y is equal to x, CR equations are satisfied. In ux, uy, vx, vy, take y is equal to x. So CR equations are satisfied. Along y is equal to x. Of course, ux, uy, vx, vy are polynomials. Ux, uy, vx, vy polynomials. So ux, uy, vx, vy, every polynomial is a continuous function. Therefore, ux, uy, vx, vy continuous functions. Dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y are polynomials. Polynomials means what? continuous functions. So ux, every polynomial is a continuous function. Vx, Vy are continuous functions. So both sufficient conditions are satisfied at one particular point. It is differentiable at that particular point. Both sufficient conditions are satisfied along y is equal to x, then f of z is differentiable. Both sufficient conditions are satisfied at one point. It is differentiable at that point. Both sufficient conditions are satisfied along y is equal to x. It is differentiable along y is equal to x. Suppose both sufficient conditions are satisfied in the neighborhood of y is equal to x, then only it is analytic along y is equal to x. That's why please pay attention. Neighborhood of y is equal to x. This is y is equal to x. What are the neighborhood on y is equal to x? We have the points 0, 0. On y is equal to x, we have the points 0, 0, 1, 1. Y is equal to x means x coordinate, y coordinate same. Now, tell me one neighborhood of the point along the line y is equal to x. Neighborhood point x is equal to 0.1, y is equal to 1.1. Neighborhood of y is equal to x line. Neighborhood of y is equal to x, 0, 0, 0.1, 0.1, 0.2, 0.2, 1, 1. Neighborhood means x 0.1, y 1.1. If I take x is equal to 0.1, dou u by dou x is 0.2. If I take y is equal to 1.1, dou v by dou y is 2.2. In the neighborhood points x 0.1, y 1.1, dou u by dou x 0.2, dou v by dou y is 2.2. That means in the neighborhood of y is equal to x, dou u by dou x not equal to dou v by dou y. Any neighborhood of 0, 0, 1, 1 point you can check. Dou u by dou x and dou v by dou y not equal. So f of CR equations not satisfied. In the neighborhood of y is equal to x. In the neighborhood of y is equal to x. So f of z is not analytic. So f of z is not analytic along y is equal to x. Therefore, integration value depends upon path, not endpoints. Therefore, integral value depends on the path integration value depends upon the path y is equal to x. Then from this dy y is equal to x, so that dy is equal to dx. Now take the problem. Five minutes, I'll give the break. X square plus iy square into dz. Now we need integration along y is equal to x. Remember everyone, We need integration along y is equal to x. First of all, x square plus I into, what is the lower limit? Lower limit 0, 0. Upper limit 1, 1. Please remember, lower limit 0, 0. Upper limit 1, 1. X square plus iy dz means dx plus I dy. But we are solving the problem along y is equal to x, so that dy is equal to dx. X square plus I into y is equal to x. And dy is equal to dx. Remember, entire problem has been converted in terms of x. So we just need x limits only. X limits only. So x limits 0 to 1. X common, x square plus 1 minute, x square plus I into y square. So x square, 1 x square common, 1 plus I into x square. Again dx common, 1 plus I into dx. So 1 plus I into 1 plus I, that is 1 plus I whole square. Integral x square dx is x cube by 3 between the limits of 0 to 1. 1 plus I whole square is 1 plus I square plus 2I. Replace x by upper limit 1. What that is 1 by 3. I square value minus 1 plus 1 cancel. Then still we have 2I by 3. 2I by 3. Just note this and try yourself. Try yourself and I'll give the break. I will not be teaching this problem. This is for you. If C is the curve, y is equal to x cube minus 3x square plus 4x minus 1. Joining the points 1, 1 and 2, 3. Then the value of integral 12z square minus 4iz dz is equal to, right? Answer minus 156 plus 38i. Let's continue after the break. Let's have a break. Very good. Minus 156 plus 38 is the right answer. And next topic. See, Miss Jahnavi, regarding this problem, CR equations are satisfied. Listen to me. CR equations are satisfied. Actually, we were asked to find integration value along this line. So, if f of z is analytic function, please stop raising hands. If f of z is analytic function along this line, then we can directly integrate. But here, again raising hand. Okay, I'll do this. So we need to verify both sufficient conditions along y is equal to x. I'll stop the class. Suppose ux CR equations not satisfied. We are asked to find the integration value along y is equal to x. So along y is equal to x, if I take y is equal to x, ux 2y, uy 0. Vx 0, Vy 2y. But if I take y is equal to x, Vy is 2x. So dou u by dou x is equal to dou v by dou y. Dou u by dou y is equal to minus dou v by dou x. So CR equations are satisfied along y is equal to x. Moreover, ux. See, you are not understanding means you need to remember the previous concepts also. Ux, uy, vx, vy are continuous functions because ux, uy, vx, vy are polynomials, so which are continuous. Both sufficient conditions are satisfied at one point, it is differentiable at that point. Both sufficient conditions are satisfied along y is equal to x line, then it is a differentiable along y is equal to x line. Suppose both sufficient conditions are satisfied in the neighborhood of y is equal to x line, then it is analytic. So on y is equal to x, we have 0, 0, 0.1, 0.1, 0.2, 0.2, 0.5, 0.5, 1, 1. These are the points along y is equal to x line. Neighborhood of these points are neighborhood of 0.5, 0.5 should be 0.6, 0.7 should be 0.65, 0.7, 0.65, 0.75, which is a neighborhood of 0, 0, 1, 1, neighborhood of 0.5, 0.5, 0.65, 0.75. If I take x is equal to 0.65, dou u by dou x is 1.3. If I take y is equal to 0.75, dou v by dou y is 1.5. Then dou u by dou x not equal to dou v by dou y in the neighborhood point. Suppose the CR equation not satisfied at any one of the neighborhood point, that meant for CR equations not satisfied in the neighborhood of y is equal to x line. So it is not analytic. That is what I said, not analytic along y is equal to x. Next, Cauchy's integral theorem. Cauchy's integral theorem. Within the brackets, simple connected region. Simple connected region means there are no holes inside the closed curve. Now this. Let us consider simple closed curve. Simple closed curve. This is a simple closed curve. The direction of the closed curve is always anti-clockwise direction. There are no singular points inside the closed curve. Everyone should remember that. Suppose f of z is analytic function inside this closed curve and f of z is analytic at all points inside the curve and also at all points on the curve. Then by Cauchy's integral theorem, we have integral f of z dz is equal to 0. Write down. If f of z is an analytic function inside and on a simple closed curve C, then integral f of z dz is equal to 0. Remember, f of z is analytic function inside the closed curve and also on the closed curve. Then the integral f of z dz around this closed curve means total work done by a force in displacing the particle around this closed curve is 0. Next, Cauchy's integral theorem for multiple connected region. Next one, Cauchy's integral theorem multiple connected region. Multiple connected region means there are some holes. There are some holes inside the closed curve. This is the first hole. The direction of every closed curve. Cherishma Errabattina, what's your doubt? Why you are continuously raising hand? This is C2. This is C3. This is CN. Sorry. The direction of the closed curve always anti-clockwise. By mistake, I have taken clockwise here. It should be anti-clockwise only. Anti-clockwise only. Write down. If f of z Mr. Nadeem Abdul, you are not understanding why you are raising hands in the middle of the class. At the end of the class, Mr. Rama Nadam also, please unmute yourself. At the end of the class, I'll talk to everybody. If you disturb, I will punish.
Ciao.
Yeah.
Okay, sir. Okay, sir.
Because in the middle, if every student asks what I teach in the class,
Wow, सडन से क्लिक हुआ ले मेरा नाम.
okay, okay. I don't. If f of z, please mute yourself. The two students. Ramanandam, please mute yourself. If f of z if f of z is analytic inside and on a simple closed curve. Remember everyone, suppose f of z is analytic function at all points inside the closed curve. F of z is analytic function at all points inside the closed curve, and also on the closed curve except at C1, C2, Cn inside and on a simple closed curve except at C1, comma C2, comma so on Cn. Means function analytic at all points inside the curve and also on the curve except at C1, C2, Cn. Then this theorem states that integral f of z dz is equal to integral f of z dz around the small closed curve C1 plus integral f of z dz around the small closed curve C2 plus integral f of z dz around the small closed curve Cn. That means total work done by a force around the big closed curve is equal to total work done by a force around the small closed curve C1 plus around the small closed curve C2 plus so on around the small closed curve Cn. Next, Cauchy's integral formula. Next one. Cauchy's integral formula. Now draw the curve. So this is one closed curve. The direction of the closed curve is always in anti-clockwise direction. Now You just assume, suppose f of z is analytic function inside the closed curve and also on the closed curve, and z is equal to z naught is some point lying inside the closed curve. I am considering the neighborhood of z naught. This small circle is a neighborhood of z naught. This small closed curve is a neighborhood of z naught. Is it okay now? See, some students are continuously entering. I am unable to check each and every question and answer and raising hands. Then I'm unable to continue. I will stop the class because you are not at all cooperating. The class will not go smooth. You must have sense being an engineering student. What should I say? You should understand, no? Now Cauchy's integral formula. Don't disturb in the middle. Cauchy's integral formula. Suppose f of z is analytic function at all points inside the curve and also on the curve, and z is equal to z naught is some point lying inside the curve. Then Cauchy's integral formula states that, write down, if f of z is analytic inside and on a closed curve C, inside and on a closed curve C, and z is equal to z naught and z is equal to z naught is some point inside the curve capital C. Then integral f of z by z minus z naught dz is equal to 2 pi I into, yeah, 2 pi I into f of z naught. Next slide. The same formula can also be written like this: integral f of z by z minus z naught whole to the power of n plus 1 dz is equal to 2 pi I into f power n of z naught by n factorial. And everyone listen to me. F to the power of n. F to the power of n means n times the differentiation of f of z. N times the differentiation of f of z at z naught. Actually, when you differentiate both sides of this equation, n times partially with respect to z naught, we get this formula. Anyhow, remember it as a formula. This is also another form of Cauchy's integral formula. Another form of Cauchy's integral formula. Remember, when do we use Cauchy's integral theorem? Everyone should listen to me carefully. There are no singular points. Listen to me, all of you. Singular point. What is the definition of singular point? Singular point means the point at which the given function is not analytic. At a singular points, function will not be analytic, will not be differentiable. So those points are called singular points. Right now, the point at which f of z is not analytic, the point at which f of z is not analytic is called singular point of the function. Remember, there are no singular points inside the closed curve. No singular points inside the curve and also on the curve. Then only Cauchy's integral theorem should be used. One or more singular points lying inside the curve, Cauchy's integral formula should be used. Next. Cauchy's integral theorem should be used if there are no singular points. Singular points means given function denominator is equated to 0. Given function denominator is equated to 0. Whatever the z values you get, those z values are called singular points. Yet those points function will not be differentiable, will not be analytic. No singular points inside the closed curve and also on the closed curve. Use Cauchy's integral theorem. You are using Cauchy's integral theorem means nothing can be solved. Directly the value of the integral should be 0. If there are no singular points inside and on a simple closed curve. When do we use Cauchy's integral formula? One or more singular points inside the closed curve, use Cauchy's integral formula. Cauchy's integral formula should be used if one or more singular points lie inside the closed curve. One or more singular points inside the closed curve, Cauchy's integral formula. No singular points inside the curve and also on the curve, Cauchy's integral theorem. Now, in real variables, circle equation is x minus h whole square plus y minus k whole square is equal to r square. H comma k is the center, r is the radius. In complex variables, circle equation is modulus of z minus z naught is equal to r. This is the equation of the circle in complex variables where center z naught is the center of the circle and r is the radius. Z naught is the center of the circle and r is the radius. Direction of the closed curve always anti-clockwise, that is positive direction, not only in mathematics, any subject anywhere. If you have a doubt how it represents a circle, simply cross check. Z. Z means x plus iy. Here Z. Z means x plus iy. Z naught. Z naught means x naught plus I into y naught is equal to r. So write the real terms in one bracket. Real terms in one bracket. That is x minus x naught plus I into imaginary terms in another bracket. That is y minus y naught is equal to r. Magnitude of one equation. Magnitude of x plus iy. Magnitude of x plus iy is square root of real part of a complex number whole square plus imaginary part of a complex number whole square. Magnitude of any complex number is square root of real part whole square plus imaginary part whole square. Squaring on both sides. So what is the circle equation? X minus x h whole square plus y minus k whole square is equal to r square. So here center of the circle x naught comma y naught. Center of the circle x naught comma y naught. Do you know every complex number should be written as point form? Every complex number should be written as point form. Real part of the complex number is x coordinate. Imaginary part of the complex number is y coordinate. So x naught plus I into y naught. It is also written as z naught. Center of the circle z naught and radius of the circle r. Next. Unit circle. Unit circle means radius of the circle should be 1. Center may be at any point. Suppose in the examination they mentioned unit circle, then you need to unit circle meaning center of the circle we don't know. Center of the circle we don't know. Radius must be 1. In the examination they mentioned unit circle. Suppose its equation is not given, then you need to assume center at 0, 0, radius 1. In case unit circle not mentioned, always assume that unit circle center at 0, 0, radius 1. That is x square plus y square is equal to 1. X square plus y square is equal to 1. So z. Z means what? X plus iy is equal to 1. Magnitude of one complex number is square root of real part whole square plus imaginary part whole square is equal to 1. Squaring on both sides, x square plus y square is equal to 1. Center of the circle at 0, 0, radius 1. Radius must be 1. Center should be at any point. In case center of unit circle not given, choose it as 0, 0. Now we do problems, and everyone should remember Cauchy's integral theorem, Cauchy's integral formula, very important, most expected topic in the GATE exam. Write down. Problem number 1. The value of integral 3 e power z plus sin hz plus 4z square by z minus 6 whole to the power of 10 z minus 8 whole cube dz, where C is the circle. Modulus of z minus 4 is equal to 1. Remember, denominator is equated to 0 whatever you get, which are called singular points of the given function. Here a denominator is equated to 0. We are getting z is equal to 6, z is equal to 8. So singular points are 6, 8. Moreover, do you know the circle equation? Modulus of z minus z naught is equal to r. Z naught value 4, r value 1. So center of the circle at 4, radius of the circle must be 1. Modulus of z minus z naught is equal to r. Z naught value 4, r value 1. Center of the circle must be at 4 and radius 1. Radius 1 means from center 1 unit out. From center 1 unit right, from center 1 unit left. Radius 1, from center 1 unit right. So from here, if I move 1 unit right, it should be 5. From center 1 unit left, 4 minus 1, 3. Now, what are the singular points? Singular points are 6, 8. So 6 will be here, 8 will be here. And you observe both singular points are lying outside the closed curve. If all singular points lying outside the closed curve, Cauchy's integral theorem should be used. You are using Cauchy's integral theorem means nothing can be solved. Directly the value of the integral should be 0. Directly the value of the integral should be 0. Therefore, by Cauchy's integral theorem, integral 3 e to the power of z plus sin hz plus 4z square. This is very, very important. I mean, Cauchy's integral theorem, integral formula, most expected topic. Every year there is a gate question, including 2020 also. Problem number 2. If C is the circle, mod z is equal to 2. Then the value of integral z square minus 1 by z cube minus z square plus 9z minus 9 dz is. Next slide. Now I can write like this. First of all, you can write numerator z square minus 1. That is okay. No change in that. Denominator z cube minus z square plus 9z minus 9 dz is equal to numerator z square minus 1. Z square minus 1 will be written as z plus 1 into z minus 1. The reason I will let you know why we need to write like this. Denominator you observe, from these two terms take out z square. From first and second terms take z square as common. So this is z square into z minus 1. From these two terms also, take 9 common. Then it is 9 into z minus 1. So this is equal to numerator z plus 1 into z minus 1. Denominator z minus 1 is the common factor. So z minus 1 into z square plus 9 into dz, here also into dz. And you observe this numerator z minus 1, denominator z minus 1 cancel. So still we have integral numerator z plus 1, and observe denominator is z square plus 9. Z square plus 9 can be written as z plus 3i into z minus 3i. Z plus 3i into z minus 3i. That means z square minus 3i whole square. That is z square minus 9i whole square. That is z square plus 9 only. Denominator is equated to 0. Whatever the z values you get, those z values are called singular points of the given function. Denominator is equated to 0. We will be getting z plus 3i. Z plus 3i into z minus 3i is equal to 0. Then we are getting z is equal to 3i comma minus 3i. Every complex number should also be written as point form. Real part of the complex number is x coordinate, imaginary part is y coordinate. 3i, real part 0, imaginary part 3. Minus 3i, real part 0, imaginary part minus 3. What is the circle? Modulus of z is equal to 2. Circle equation, modulus of z is equal to 2. General form of circle equation is z minus z naught is equal to r. From that, the center of the circle is 0, 0. Radius of the circle is 2. Center 0, 0, radius 2. If radius 2, then this is 2 comma 0. If radius 2, it is minus 2 comma 0. Radius 2, it is 0 comma 2. This is 0 comma minus 2 because radius 2. This is mod z is equal to 2. What are the singular points? 3i comma minus 3i. 3i. 3i means 0 comma 3 will lie here. Minus 3i means 0 comma minus 3 will lie here. Both singular points are lying outside the closed curve. Both singular points are lying outside the closed curve. Therefore, by Cauchy's integral theorem, CIT, Cauchy's integral theorem, then equation number 1 will be written as 0. That is integral z square minus 1 by z cube minus z square plus 9z minus 9 and dz is equal to 0, because all singular points will be outside of the curve. Next, problem number 3. The value of the following complex integral with C representing the unit circle centered at origin in the counterclockwise. Everyone remember, anti-clockwise direction is also called counterclockwise direction, also called positive direction. In the counterclockwise sense, means in the positive direction. In the positive direction is C, this is z square plus 1 by z square minus 2z dz. Option A, option B, option C, option D. This problem given in the GATE 2020 electrical engineering. But they have clearly said center of the circle 0, 0, radius of the circle 1, unit circle. Unit circle means radius must be 1. But center also they mentioned. So center at 0, 0, radius 1. Let me draw center of the circle at 0, 0 and radius 1. In such a way you can draw a circle. If radius 1, it would be 0, 0 and this is 1, 0. If radius 1, it is 0, minus 1. If radius 1, it is minus 1, 0. This is 0, 1. Now let us solve. The given problem is integral z square plus 1 by z square minus 2z into dz. This is equal to integral z square plus 1 by z square minus 2z Z is the common factor, take it out. Therefore, it is a Z into Z minus 2 dz. What are the singular points? Z is equal to 0, comma 2. Denominator is equated to 0. Which are the singular points? Which are the singular points? Denominator is equated to 0. Whatever you get, which are called singular points of the function. Now you observe Z is equal to 0. This is Z is equal to 0. Z is equal to 2. Z is equal to 2 means 2 plus I into 0. 2 plus I into 0, that is real part 2, imaginary part 0. So that number should be 2 comma 0. Here 2 comma 0 lying outside. Remember, when you are solving any problem regarding Cauchy's integral theorem and Cauchy's integral formula, any singular point lying inside the closed curve, any singular point lying inside the closed curve must be kept in the denominator itself. Any singular point lying outside the closed curve should be taken in the numerator. Any singular point lying inside the closed curve should be kept in the denominator itself, and any singular point lying outside the closed curve should be taken in the numerator. Z minus 2 is equal to 0, Z is equal to 2 lying inside the curve. So Z minus 2 will be taken in the numerator and Z will be in the denominator. As I told you already, one or more singular points lying inside the closed curve, Cauchy's integral formula should be used. Before going to use Cauchy's integral formula, any singular point lying outside the curve must be kept in the numerator itself. That is 2. That is Z minus 2. Now, what is Cauchy's integral formula? This is Z square plus 1 by Z minus 2. Here denominator is Z. This Z, I can write it as Z minus 0 dz. What is Cauchy's integral formula? Integral f of Z. Cauchy's integral formula is f of Z by Z minus Z naught. F of Z by Z minus Z naught. What is the formula? That is 2 pi I into f of Z naught. Cauchy's integral formula, integral f of Z by Z minus Z naught dz. 2 pi I into f of Z naught, that is 2 pi I into f of 0 is 0 square plus 1 by 0 minus 2. So this is 2 pi I by denominator minus 2. 2 cancel. Therefore, the answer is denominator minus symbol will go numerator, so minus pi I. Next, problem number 4. The value of integral Z minus 1 by Z square plus 1 dz, where C is the circle, modulus of Z plus I is equal to 1. Problem number 4 I will teach. You can solve problem number 5. The value of integral e power z by z square plus pi square whole square dz, where C is the circle mod Z is equal to 4. I will teach the first problem right now. Second problem, I mean fifth problem, you can try. Of course, I will give you the answer for the fifth problem. Fourth problem. Let f of z is equal to z minus 1 by z square plus 1. Denominator z square plus 1 can also be written as denominator z square plus 1 can also be written as z plus I into z minus I. That is z square minus I square value minus 1, minus into minus 1 plus 1. So the singular points z is equal to I comma minus I are singular points. Every complex number should also be written as point. Real part of I 0, imaginary part of I 1. Real part of minus I 0, imaginary part of minus I 1. So 0 comma 1 and 0 comma minus 1 are the singular points. And now, what is the center of the circle? Center of the circle is C. Circle equation given. Please be careful. Circle equation is modulus of, I will draw the diagram and I will explain like this also. Z plus I is equal to 1. Listen to me, I will explain in two different ways. One of the method is first to substitute one singular point in place of Z, resulting answer greater than right side number outside, resulting answer less than right side number inside. What I said, substitute the singular point in place of Z, resulting answer greater than right side number outside, less than right side number inside. If I take z is equal to I, then it is I plus I, that is 2I. Modulus of 2I, modulus of one complex number is square root of real part whole square plus imaginary part whole square. That is root to 2, root 4, 2, greater than 1. So this is outside. Substituting the singular point in place of z, resulting answer greater than right side number outside, less than right side number inside. Now z is equal to minus I. Take z is equal to minus I. Minus I plus I, that is modulus of 0, that is 0, less than right side number. So it lies inside the given closed curve. Lies inside the given closed curve. Now we can directly solve diagrammatically also. Let me explain both the ways. What is the center of the circle? Here z plus I can be written as z minus of minus I. Z plus I can be written as z minus of minus I. So center of the circle minus I. Minus I means it should be written as z minus of minus I is equal to 1. Center of the circle minus I. Real part x coordinate, imaginary part y coordinate. Radius of the circle 1. So draw one circle whose center at 0 comma minus 1. Draw one circle whose center should be at 0 comma minus 1. One circle has been drawn whose center at 0 comma minus 1. Radius 1. Radius 1 means from center exactly 1 unit up. From center exactly 1 unit up should be 0, 0. So this is x-axis. Center at 0 comma minus 1, radius 1. So from center 1 unit up, 0 minus 1, from there 1 unit up means 0, 0. And from center 1 unit down, that is 0 comma minus 2. 0 comma minus 2. What are the singular points? Singular points are 0 comma 1, 0 comma minus 1. Singular points are 0 comma 1, 0 comma minus 1. Here 0 comma 1 will be here, 0 comma minus 1 will be here. This is 0 comma 1, this is 0 comma minus 1. Using diagrammatically also we can explain. Solving the problem easy, okay, that is okay, you are able to solve. Now take the given function integral z minus 1. Try the second problem also. By z square plus 1 dz, that is z minus 1 by z square plus 1 will now be written as z plus I into z minus I dz. Whatever the singular point lying outside the closed curve should be brought to the numerator. The singular point lying outside the given closed curve is I. I means 0 comma 1. I can be obtained from z minus I. So z minus I should be kept in the numerator only. And denominator z plus I dz. So I can write like this. I can write like this. Next slide. Z minus 1 by z minus I denominator z plus I. Z plus I can be written as z minus of minus I into dz. So this is one or more singular points inside the given closed curve Cauchy's integral formula. This is integral f of z by z minus z naught. Integral f of z by z minus z naught dz. Then it is 2 pi I into f of z naught. That is equal to 2 pi I into f of minus 1. So that is minus I, f of minus I. So z should be replaced by minus I minus 1 by minus I minus 1. Minus I, sorry. This is 2 pi I into numerator minus I minus 1. Denominator minus I, that is minus 2I. 2 cancel, I cancel. So denominator minus symbol is there, it will go numerator. That is minus pi into minus I minus 1. So minus pi into minus I, that is pi I. Minus pi into minus 1, that is pi. So answer pi into 1 plus I. Next, note this and try yourself. Let f of z is equal to 1 by z plus a greater than 0. Multiple connected region we solve. Wait, a greater than 0. Everything will be solved. Why you are worrying? And the value of integral f of z dz over a circle C with center minus a comma 0 and radius capital R evaluated in the anti-clockwise direction is dash. Option A 0, option B 2 pi I, option C minus 2 pi I, option D 4 pi I. So option B correct. Try yourself. This problem given in the gate instrumentation engineering 2020. Problem number 7. Problem number 7. D contour capital C given below is on the complex plane z is equal to x plus iy. I mean x plus jy. Sometimes in place of I, we can take j. J is equal to root of minus 1 means I, and draw this diagram. Remember two singular points lying inside the closed curve, which are -1 and +1. Next slide. Next slide. The value of the integral 1 by pi j integral dz by z square minus 1 is dash. This problem given in the GATE Electronics Engineering 2018. Remember everyone, more than one singular point lying inside the closed curve. More than one singular point. Two or more singular points lying inside the closed curve. Before solving, you need to split the given function into partial fractions. Look here, two singular points are inside the curve only. Everyone should remember more than one singular point. I mean two or more singular points inside the closed curve. Before going to solve the problem, split into partial fractions and then proceed further. This is partial fractions. Split is required. This is z plus 1 into z minus 1. You can split into partial fractions, or else you can do like this also. Even this is also the right way only, 1 by 2 into. What I do is subtraction of the denominator two terms must be written in the numerator. The alternate method of partial fractions is only in case of linear factors, then addition or subtraction of denominator two terms must be written in the numerator. That is, numerator should be z plus 1 minus of z minus 1. What the numerator is? Plus z minus z cancel. 1 minus of minus 1. 1 plus 1, 2. So the denominator is z plus 1 into z minus 1. Numerator is 2. Denominator is 2. Then we will get the same value. So this is 1 by 2 into, split this, z plus 1 by z plus 1 into z minus 1. That is 1 by z minus 1 minus z minus 1 by z plus 1 into z minus 1. That is 1 by z plus 1. Integrate with respect to z both sides. Integrating with respect to z both sides. Integrating with respect to z means integration of 1 by z minus 1 dz minus integration of 1 by z plus 1 dz. Both singular points inside the curve only. So 1 by 2 into, I can write like this, 1 by z minus of z naught dz minus, and everyone, one small request, please look at the diagram. Look at the diagram. 1 minute. 1 minute. This is C, the curve. Look, the singular point 1, the singular point minus 1 lying in this loop. Everyone stop writing and listen. the singular point -1 lying in this loop. The first loop, left loop direction clockwise or anti-clockwise? Left loop direction clockwise direction. Clockwise direction means your integral value must be multiplied by -1. Left loop containing singular point -1 and its direction is clockwise direction. So clockwise direction should be integral value should be multiplied by -1. So left loop containing singular point -1. Here, this is the singular point. Second integral singular point is -1. Therefore, your integration value should be multiplied by -1. Your integral value should be multiplied by -1. -1 into this minus becomes plus. Minus into minus plus. By 1 by z plus 1 will now be written as z minus of -1 into dz. Why I have taken plus symbol here? Because this is clockwise. And singular point 1, that is in which loop? Singular point 1, that is in the right loop. Right loop direction is clockwise only. If its direction is clockwise, no need to multiply anything. I mean positive symbol only. Anti-clockwise. Right loop is anti-clockwise, left loop is clockwise. If it is clockwise, multiply your integral by minus symbol. Now, this is 1 by 2 into, and observe this, integral f of z by z minus z naught. Integral f of z by z minus z naught. Cauchy's integral formula. Integral f of z by z minus z naught, that is 2 pi I. I means j. 2 pi I into f of z naught means 1 plus 2 pi I means j, f of z naught means -1. So from this, 1 by 2 into 2 pi j, 2 pi I, f of 1, that is 1, plus 2 pi j, f of -1, also 1. This is a 4 pi j by 2, that is 2 pi j. Problem not yet completed. Problem not yet completed. We were asked to find, multiply both sides of this integral by 1 by phi j. 1 by phi j. Then it is 1 by phi j into integral dz by, let me complete the problem, man. You must have patience. Wait for 2 minutes. Z square minus 1 is equal to 1 by phi j. This is 2 pi j. 1 by phi j into 2 pi j. And you observe this pi j cancel. Then answer should be 2. So my humble request to everybody, more than one singular point lying inside the closed curve, more than one singular point lying inside the closed curve, split into partial fractions and then proceed further. You just try this, try yourself. I'll stop the class, note this and try yourself. Where C is the boundary of the square, with vertices two comma two, minus two comma two, minus two comma minus two, and two comma minus two. Try yourself. Both singular points are lying inside the closed curve only. So you need to split up into partial fractions and then proceed further. Now I'll take the doubts. Okay, 1 minute. 1 minute. 110 slide, question number 5.
Yes, sir.
Hectic. Again, after that, also
Okay.
we'll be like using our phones and all.
Question number 3. Sir.
One.
Sir, question number 3.
Question number
3. Solution.
See, bro, once you go to the word, I will also go to
Solution,
the word
solution.
morning. So whatever are there
Last
questions,
f of
if
z
I
by
have-
z naught.
if I have any doubt, I'll
Z
send
naught.
to you. And you have any doubts,
Last
just we'll
integral.
make a point
Next,
out of it.
next slide, sir.
somebody is
And
talking.
we'll ask them.
Hello. Hello.
Tell me.
Sir.
Yeah. Morning, I'll
Hello?
do the same thing. Whatever I have the doubts, no,
Hello.
I'll send to you. How I open,
Hello?
I'll do that work only
Talk
first.
to me.
Hello, sir.
Then we'll discuss in that meeting.
Hello.
If Ajit thinks to assign me tomorrow,
Sir, 108,
to,
sir. 108.
then I'll ask
Go
him
to
all
108,
these
sir.
questions.
Sir, 108
Hello,
slide.
sir.
I guess.
108.
If he thinks of assigning, yeah, then I'll ask him before only.
Sir, how we
All
are
these
taking this
questions,
problem until an
And I'll
experiment?
send you that.
I'm not getting what you are speaking. Somebody is talking.
Whatever he
Please unmute
replies, no,
other
I'll just
students.
Hello.
Voice not clear or little bit loud and tell me.
That today's
Hello. How we are
incident thing,
taking
no?
this f of z,
Today's
z by z
incident
naught
thing.
at value?
I
Here
said
2
you
pi
know to
f
check
that
that
value.
mail.
1 minute. I'm not getting. Somebody
He
is
was
talking.
taking follow-up. I was in break.
Please
Hello?
unmute. Other students,
Hello?
please unmute. Otherwise, I will end the session.
Hello.
Wait, man. 1 minute. Wait. Let me check.
Okay, sir. Okay, sir.
What's your name?
Nadeem.
Nadeem, tell me.
Sir, here z square plus 1 by z naught is formula I didn't get. I didn't understand, sir. Next slide. 108.
Total 2 slides, 0 and 2.
Okay.
Are you getting?
Your nod is not clear, sir.
Your voice is not clear. My voice is clear or not?
Clear now. It is clear. Tell.
Total how many singular points lying inside the closed curve?
2. 0, comma 2. 2.
One singular point 0, 0 inside. Other singular point 2, comma 0 outside 2.
Okay.
So singular points lying outside the closed curve should be lying outside the closed curve should be taken in the numerator. 2 lying outside. 2 singular point obtained from z minus 2. So take z minus 2 in the numerator. Other singular point 0 inside the curve only.
The work
So
notes
that's
we
why 0 singular point obtained from z. So please keep that z in the denominator itself. Now Cauchy's integral formula. One or more singular points inside the closed curve, Cauchy's integral formula should be applied. So that's why, what is Cauchy's integral formula? Please
2
remember
pi
the
f.
formulas.
2 pi f.
And I will write
2 pi f.
z minus 0. Z can also be written as z minus 0. Cauchy's integral formula f of z by z minus z naught dz. What is that formula? 2 pi I into f of z naught.
F of z naught.
Okay, please mute yourself after completion. Those have
Okay, sir.
already completed.
Sir, good
Hello.
evening, sir.
One by one. Why
Sir,
it is
please upload.
all?
Sir, please.
Next to Pranita.
Yes, sir.
Tell me.
Sir, my doubt is, sir, please upload the notes on daily basis, sir.
Why?
Sometimes it will be missing, sir. That's why.
Your voice is not clear.
Hello. Sir, my request is, sir, please upload the notes on daily basis, sir. Okay.
That is fine. I'll ask them to upload. They told me that they will upload after the end of the session. Anyhow, I will upload 2 days class.
Hello, sir.
Okay,
Hello, sir.
Yesterday's class is not uploaded. That's why, sir.
Because most of the students' voice is not audible. Please, please, please talk loudly.
Okay, sir. Hello.
Okay, okay, sir.
Pranit, yours completed,
Complete, sir. That's only, sir, my doubt. Okay.
And mute yourself.
From morning food I have get up, that's it.
Next, Nadeem.
Sir, yesterday you did organic function.
No, your voice is not clear because somebody is talking.
Hello. Hello, sir. Yesterday's class in that harmonic function you were not telling. I missed. I told no, sir. You didn't tell me harmonic function.
Because voice not clear. Some who is talking, some other one girl is talking. What she is doing, I don't know. They don't know. It is typical, so that we can end the session. I am not able to understand. Because if you continuously tell me, Mr. Nadeem, which slide? Nadeem? Nadeem? Nadeem?
Sir, good evening, sir.
Who is this? Name?
Balaji, sir.
Balaji, tell me.
Sir, 87 frame, sir. 87.
Okay, little bit loud. It is
Okay, sir.
87. Okay, na?
Okay, sir. Sir, if it's not a analytic function, sir. Sir, then we which curve we have to use, sir? Y is equal to x or y is equal to x square?
See, if it is not analytic function, then you need to find integral z dz value along y is equal to x separately, and you need to find integral z dz value along y is equal to x square separately. Two problems. This problem.
Then at last we have to add now, sir.
No. We are not asked to add no. Two problems. We were asked to find along this separately. Here what I am showing is when you add along this curve or when you find along this curve or along this curve between the same 2 points, answer will not change. That's why I have drawn. It is not required to add. Separate only problems.
The both answers will be same now, sir.
Both answers should be same if you solve in the same manner of previous problem model.
Okay, sir. Okay, sir. Sir, if any question, if given clockwise, we have to multiply with -1, sir.
Any problem in the examination, clockwise direction is mentioned. You need to multiply your answer by minus symbol.
Okay, sir. Okay, sir. Thank you, sir.
Yours complete,
That's it, sir. That's it.
Please mute yourself. Next, one by one. Next to Manideep. Manideep, please unmute yourself.
Hello, sir.
Tell me, Manideep.
Sir, in yesterday's class, page number 37F.
Page number 47.
37. 37.
Okay. Tell me.
Sir, in this, we applying the limits. CI equation not satisfied. We applying the limits at 0, 0,0, no, sir.
Voice a little bit loud.
CI equation 0.0, no, sir. Applying. Hello, sir.
CR equations 0,
0 we are applying, no, sir.
Yes.
For any problem, we apply CR equations. It is satisfied, no sir. 0,08.
See, actually, CR equations not satisfied. Dou u by dou x not equal to dou v by dou y. Correct?
Yes sir.
Dou u by dou y not equal to dou u by dou y not equal to dou v by dou x. Whenever CR equations are not satisfied, then we need to verify CR equations at the option points. Options. What are the options in the problem? 0, 0. That's why I am checking CR equations at 0, 0. CR equations at 0, 0 satisfied. You understand?
Yes sir.
First CR equations are satisfied at 0, 0. What are ux, uy, vx, vy? 0, 0, 0. No? Every constant is also a polynomial. So every polynomial is a continuous function. So ux, uy, vx, vy are continuous functions. CR equations are satisfied at 0, 0. Ux, uy, vx, vy continuous at 0, 0. Means two sufficient conditions are satisfied at 0, 0. Therefore, it is differentiable at 0, 0. Suppose two sufficient conditions are satisfied in the neighborhood of 0, 0, then it is analytic at 0, 0. That's why I want to choose one of the neighborhood of 0, 0. One of the neighborhood of 0, 0. Let it be 0 0.1, 0 0.2. X value 0 0.1, Y value 0 0.2. That is the neighborhood point of 0, 0. See, CR equations must be satisfied at all points in the neighborhood. So X value 0 0.1, Y value 0 0.2. If I take Y value 0 0.2, UX value 0 0.2, Vy value 2 into 0 0.2 means UX value not equal to Vy. Are you getting?
Yes sir.
So in the yet one of the neighborhood point, CR equations are not satisfied. Even CR equations are not satisfied at one point in the neighborhood, then it will not be analytic.
Okay sir.
Is it clear?
If CR equations not satisfied, then we go for options. Sir.
Yes, yes, yes. We have to go for options and check CR equations at the points which are available in the options.
Sir, page number 60.
Page number
60.
60.
Yes, sir. So next 60, sir. 60.
This is 60 only. This is 6.
Sir, this problem not understand how to do, sir.
Which one?
This third one.
Similar to the previous problem model you given, we find last class yesterday how I taught the problem, same model.
Okay, sir. Previous one, sir.
This problem, previous problem model only.
Okay, sir.
Problem model only you can solve third problem.
Okay, sir. Thank you.
Second problem model only. Third problem, second problem model only. This one,
The third one, sir. Third one.
This one similar to the previous problem model. Second problem model only.
Okay, sir.
Okay, na?
Okay, sir. Thanks.
Any other?
No, sir.
Please mute yourself. I'll talk to next
Hello,
to
sir.
Shweta.
Hello,
Sir,
sir.
am I audible, sir?
Sir, I have
Hello.
hello.
Talking.
Hello.
Hello.
Hello, sir.
This is Shweta.
1 minute. 1 minute. In the line sequential order, first to Sweta, next to Sri Kiran, next to Shashank Chila. This is the sequence. Sweta, please unmute and talk.
Yes, I have unmuted. Sir, actually, I have a request. No matter how many times you'll instruct somebody, there will always be some students who will not go according to it. So it's better to ignore them because it disturbs the whole class then. And
yes.
they don't are not sensible enough. It's we cannot do anything about it, but it will be great if you don't pay attention to it.
Sure. Tomorrow onwards, I will before starting the class, I will do that.
Okay, and also, so if doubts would be addressed only in doubt session, that would be great.
Pardon?
If doubts would be addressed only in doubt session, that would be great too, because some people who don't have the same doubts get to listen to the same thing again because of some one or two people's doubt. Thank you so much, sir. That's all.
Please mute yourself. Next to Sri Kiran.
Hello, sir.
Tell me.
Sir, if
Sri Kiran, tell me.
Hello.
Tell me.
Sir, if you have two singular points outside the circle, sir, unit circle, and a singular point on the radius of the unit circle, sir, then what we have to follow approach? Either theorem we have to follow or the formula, sir?
No, singular points lying on the curve, then we should not use Cauchy's integral theorem or Cauchy's integral formula. Some other procedure by converting to polar coordinates, by assuming polar coordinates are z is equal to r e power I theta. By converting to polar coordinates, we need to solve.
Okay, sir. Means it is applicable only either outside or inside.
Not apply integral theorem or integral formula.
Okay, sir. Got it. Sir, another note, sir. Sir, in today's session, you said that if a function is differentiable along a line, sir, then in that case, how to check the analytics, sir? Means on that line, every b-side points you have to check, sir.
It is a differentiable at all. Both sufficient conditions are satisfied along y is equal to x. Correct?
Yes, sir.
So it is a differentiable along y is equal to x. Suppose both sufficient conditions are satisfied in the neighborhood of y is equal to x. Y is equal to x, what are the points on it? 0, 0, 0.1, 0.1, 0.2, 0.2, 0.9, 0.9, 1, 1. Neighborhood of these points is 0.62, 0.72 like that. Correct or not?
Yes, sir.
So in the neighborhood points, you need to verify CR equations.
Okay, sir.
Understand or not?
Yes, sir. Got it, sir. Means any on that line and at any point we can take the neighborhood points and we can solve.
Surrounding neighborhood points, x 0.72, y 1.2, like that.
If on that line there is a point of 0, 7, 0.7, then we can take 0, 6, 0, 5 like that.
No.
Nearby point.
Point should be completely neighborhood. On the line we have 0.00, 0.1, 0.1, 0.2, 0.2, 0.6, 0.6, 0.7, 0.7. Neighborhood means what? Outside. That is 0.82, 0.7, 0.82 like that. 0.81, 0.91 like that.
Okay, sir. Got it.
Next.
Thank you, sir.
Next.
Sir, good evening, sir.
Next to Shashank, next to Manideep. Tell me, Shashank.
Sir, good evening, sir.
Good evening.
Sir, page 93F, sir. 94. I mean, next problem, sir. You have given one problem as homework, no, sir? Yes, sir. This I did not understand this question, sir.
See, you are asked to see problem number 1, 2, 3 model only. Here, this is analytic function. 12z square minus 4iz. Is it a polynomial?
Sir?
You didn't understand. Look here, how did I solve this problem? If it is analytic function, direct integration, no.
Yes, sir.
Look here, integral z dz. Z is a polynomial?
Yes, sir.
So it is analytic everywhere?
Yes, sir.
So direct integration, integral z dz is z square by 2. Correct?
Yes, sir.
And now here, this is a polynomial. Z power any positive, z power any non-negative integer is a polynomial.
Yes, sir, it's
polynomial, Z polynomial. So it is analytic in everywhere. Direct integration. Integral 12z square is 12z cube by 3. Integral 4iz, 4iz square by 2.
Oh, okay, sir. Sir, and how to consider the limit, sir?
Even no, here lower limit 1, 1 means 1 plus I. Upper limit 2, 3 means 2 plus 3i.
Okay, sir. That's all, sir. Thank you, sir.
Okay. Next, Manideep. Unmute. Next, Sindhu. Manideep.
Sir. Hello, sir.
Tell me, Manideep.
Sir, page number 74.
74.
Sir, in this first one, how you use a harmonic function, sir?
Any function that satisfies a Laplace equation, that is called harmonic function. Suppose u satisfies Laplace equation means dou square u by dou x square plus dou square u by dou y square is equal to 0. Then we can say that u satisfying Laplace equation. If u satisfies Laplace equation, u is called harmonic function. So here dou square u by dou x square plus dou square u by dou y square 0. Because dou square u by dou x square 0, dou square u by dou y square 0. So dou square ux x by dou square u y is equal to 0. Means u satisfying Laplace equation. Therefore, u is called harmonic function. Yesterday, I gave the definition of harmonic function. Did you remember?
I remember, sir.
Is it clear?
Okay, sir. Sir, 84. 84.
Huh?
84. Page number. Sir, in this CR equation not satisfied means f of z is not analytic also.
Yes, CR equations not satisfied, it is not analytic. I have written now CR equations not satisfied, it is not analytic. If it is not analytic, then integration value depends upon the path. What is path? Y is equal to x square. Integration value depends upon the path means path equation must be substituted in the given problem.
Sir, in next problem, f of z equal to z means it is an analytic also.
It is analytic. It is analytic means what? Integration value depends upon the endpoints, not on the path. Integration value depends upon the endpoints means directly you integrate and substitute upper and lower limits.
Okay, okay, sir.
Is it clear now?
Clear.
Unmute yourself. Mute yourself. Lakshmi Prabha.
Yes, sir. Good evening, sir.
Amulya.
Good evening.
Good evening. Tell me, Amma.
Sir, is the linear algebra already done?
Yes, yes.
Sir, but in the site I can't see the notes or recorded video.
No, it will be taught you. At that time you didn't join, huh?
Yes, sir.
No, it will be taught again.
Okay, sir. Okay.
That's it, Amma.
So one more personal request, sir. For me, when I'm watching the screen, it's the size is high, sir. So when I fit to window, I choose it's blur, little bit blur, so I can't able to follow it. So I don't know how to rectify it, but
then better to talk to the concerned in charge. They will let you know. They will let you know how to rectify that issue.
Okay, sir.
Please talk to them. They will let you know.
Okay, sir. Thank you, sir.
And next. Next, Amulya completed.
No, sir. Good evening, sir.
Tell me, Amulya.
Sir, in page 91, sir.
Next to Sindhu. Page 91.
Sir, here I didn't get how you wrote Vy is equal to 2x, sir. It should be 2y, no, sir.
Vy is equal to
2x.
By mistake I have written. Sorry, by mistake I have written.
Okay. Sir, and here Uy is not equal to minus Vx, no sir. So then CR equations are not satisfied, no sir.
So Uy is equal to minus Vx, but Ux not equal to Vy, no?
Yes sir. If Ux equal to Vy,
1 minute,
and
1
then
minute. No,
okay sir.
Wait. 1 minute. Vy
Yes.
is equal to 2x only. What I have written is correct. Listen. Here, what is Vy? 2y, yeah?
Sir, your voice is breaking, sir.
What is Vy? Is it clear now?
No, sir, your voice is breaking, sir. Vy is
Minute.
y it is 2x, sir.
Now voice, is it clear?
Yes, sir. Yes, sir.
Look, what is Vy? Vy is 2y, correct?
Yes, sir.
But we are solving along y is equal to x. Hello? Hello? Is it audible? Is
Audible,
it
sir.
audible?
Yes, it's audible.
Vy is equal to 2y. But we are solving along y is equal to x. When you are solving along y is equal to x, you need to substitute y is equal to x. So Vy is 2y. Take y is equal to x. Therefore, Vy is equal to 2x. Hello? Hello?
Sir, you are audible, sir.
But you are not responding. That's why I'm getting the doubt. Is there any voice problem is there?
Sir, I am not the one who was straight out.
So that girl is disconnected.
Now voice clear and everything is fine?
Sir. Yes, sir.
Doubt, ask me doubt. Vy is 2x along y is equal to x. What is the doubt?
Sir, that girl disconnected, I think, sir.
Which is disconnected?
The girl who asked the doubt.
Huh?
So can you go to page number 62?
Igama.
Okay, so I wanted to see the answer, correct answer.
You are not getting the answer?
So I got, sir. I didn't take that time. So now page number 85.
Is it okay now?
Yes, yes.
Okay.
85.
Okay, fine.
So 85.
This is 85 only.
Okay. So this question, first question, so I think one page back.
This one, huh?
Yes, sir. So here you were, initially you explained something that the curve is open and when the curve will be closed, you were saying something.
1 minute. Curve is a closed curve. That problem should be solved using integral theorem or integral formula. Suppose the curve is not a closed curve, then it should be solved like this only. We need to check whether f of z is analytic function or not, and then we need to check.
Okay, means when the curve will be closed, then we will use that Cauchy's integral formula or Cauchy's integral theorem.
Curve is a closed curve, integral theorem or integral formula. Curve not closed this way. Problems 1, 2, 3, 4 model.
Okay, sir. Sir, and yes, sir.
Tell me.
Sir, last doubt is means what is the significance of this singularity in Cauchy's integral? Means when we will come across practically.
Singular point means at that point, the point at which function will not be differentiable is called a singular point. The point at which function will not be differentiable is called a singular point.
So it means that in an analytical surface or area, there will be some point that is not differentiable.
1 minute, Amma. Tell me.
So I was saying that if there is, means there is some curve in which there is some point z0 and that point is singular, then only that point will be not differentiable and all other points will be analytic around that.
Yes, I didn't get what you are asking. Where Z0? Z0 where it should be?
Sir, Cauchy's integral.
That is okay. I didn't get what you are exactly asking. Singular.
Sir, I just want to know the significance in which subject or when we'll come across this singularities and Cauchy's integral theorem, practical significance. Something.
Here you have no, suppose the function is not defined. Actually, the function is not defined at any particular point. Integral 1 by x minus 1 dx. So integral 1 by x minus 1 dx. Suppose actually this model purpose is finding the work done by a force around a closed curve. Integral f of z dz. F of z is force, dz is displacement. Integral means total work done by a force. If the force function is not defined at any particular point, then how can we find? Singular point integral f of z dz, that is total work done by a force inside the closed curve. Suppose f of z is not defined at any point inside the closed curve, then how to find the total work done by a force in displacing the particle around a closed curve? That is the meaning of singular point inside the curve. At that point, the force function f of z will not be defined.
Okay, sir. Got it. Thank you.
Next.
Good evening, sir. Can you open 70F?
70?
If
70, Amma?
72, sir. Sir, after getting v equal to 2xy, should 1 comma 1 should be substituted in it?
2 into 1 into 1, 2.
Then we get 2. Why did they give 1.99 and 2.01?
Gate kill is the answer is any number between 1.9 and 2.1 will be the answer. Suppose your answer is 1.999, then it is nearly 2 no. That means when you calculate these values from CalC, sometimes it may up to 10 decimal places, it may give 1.9999. It is not a round off number.
Okay, sir, got it, sir.
But in the exam, roughly you can write, not compulsory to write exact value.
You were speaking about volumes, volume 1 and volume 2. I just got workbook, sir. Are you speaking about level 1 and level 2 problems in the workbook?
Volume 1 means the classroom practice booklet that the concerned faculty will teach.
Okay, sir.
Volume 2 means you may be given one book of practice questions with the details about it.
Yes, sir. Thank you, sir.
That's it, Amma.
Yes, sir.
Next, Kiran Ganpat.
Sir, answer of question number 5 answer.
Yesterday's class, huh?
No, today's class, sir.
Slide number, do you remember?
No, sir.
Okay, question number 5. Which model?
It was last question. It belongs to last model, I guess. Here it should be
models only, yeah?
It's okay. It's
-5.
I am getting minus 1 by pi I, so that is why
minus 1 by
pi I.
No, check it once again, you will get the answer. What I gave is correct. Please once again check, still not getting, tomorrow I'll teach. Minus pi I is correct. Hello?
For this.
Huh? Hello? Not audible.
So can you give hint for this?
Not audible.
What are the roots? Roots are.
Huh? Your voice is not clear.
Audible, sir?
Okay, tell me.
Not audible. Your voice, there may be network issue. Hello. 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 Next, Akanksha. Unmute. Akanksha.
Sir, done.
Huh? Akanksha.
Yes, completed.
Huh?
Doubts are done. So you're clear.
Ah, fine, fine. Next, Amulya. Amulya completed. Next, anybody else? Anupama Reddy. Anupama
Hello,
Reddy.
sir.
Tell me, Amma.
Sir, 92F.
చాలాసేపు నుంచి వెయిట్ చేస్తున్నట్టు. 92F. Tell me.
Sir, here I didn't understood why it is not satisfying CR equation.
Where?
I mean, CR equation. It is not analytic, no, sir. Why it is not analytic? You said that the neighborhood is not satisfying.
This problem, up to here, where did you understand? Did you understand CR equations? F of z is differentiable along y is equal to x.
Yes, sir, I understood. After that, I didn't understand.
Up to second step, did you understand? No.
Yes, sir.
F of z is differentiable along y is equal to x. You understood up to that?
Yes, sir, understood.
Now, actually, remember, both sufficient conditions are satisfied at one point. It is differentiable at that point. Both sufficient conditions are satisfied in the neighborhood of one point. It is analytic at that point. You are given y is equal to x. Both sufficient conditions are satisfied along y is equal to x. So it is a differentiable along y is equal to x. In case both sufficient conditions are satisfied in the neighborhood of y is equal to x, then it is analytic along y is equal to x. This is y is equal to x. What are the points on the line y is equal to x? The points on the line y is equal to x are 0, 0, 0.1, 0.1, 0.2, 0.2, 0.5, 0.5, 0.9, 0.9, 1, 1. Neighborhood of these points, tell me one point yourself.
0.6 is 0.6.
0.6, 0.6 will lie on y is equal to x, no? X 0.6, y 0.6.
Yes, sir.
Neighborhood. What are the points on the line y is equal to x between 0, 0 and 1, 1? 0, 0, 0.1, 0.1, 0.2, 0.2, x 0.2, y 0.2. Because it is y is equal to x coordinate, y coordinate same.
Yes, sir.
Tell me some.
That's why I'm saying 0.6, sir.
0.
Okay. 6, sir.
0.6. Not
yes, sir, that lies in y is equal to x, right, sir?
That line is y is equal to x. But this line lies between 0, 0 and 1, 1, whose x coordinate and y coordinate are same because the line is y is equal to x.
That's why it should be analytic, no, sir. I mean,
1 minute, Amma.
it is satisfying.
1 minute. See, both sufficient conditions are satisfied along y is equal to x. It is differentiable along y is equal to x. Both sufficient conditions are satisfied in the neighborhood. Suppose this is y is equal to x. Neighborhood of y is equal to x means these points. Outside neighborhood means some little x are. Neighborhood means.
Okay, sir, I thought on the line.
Neighborhood of y is equal to x means a little bit outside of y is equal to x line.
Okay.
Is it clear?
Okay. Yes, sir, clear, sir. And 94F.
94F.
Sir, in the homework problem, can we integrate directly because it is a polynomial equation,
Yes.
right, sir?
Yes, you can integrate directly. Substitute the lower limit 1 means 1 plus I. Upper limit 2 3
And
means
2 plus 3i.
you will get that answer after simplification.
Okay, sir.
That's
And
it.
102, sir.
Okay, fine. 102. Tell me.
Sir, I have a doubt, sir. Why we are taking singular points as a denominator value, sir?
Singular point means the point at which the function will not be differentiable, will not be analytic, is called a singular point. At the point at which function will not be analytic is called a singular point. Analytic will not be analytic means what? Will not be differentiable. Will not be differentiable means what? Will not be defined. Will not be defined means what? The point at which the given function becomes infinity. At those points, function will not be defined. Will not be defined means will not be continuous, means will not be differentiable, means will not be analytic.
Okay, sir. And sir, can you please explain this problem, sir? I didn't understood. I mean, I lost connection when you're explaining this.
Look there, what is the theorem statement? All singular points outside the closed curve use Cauchy's integral theorem.
Yes, sir.
Denominator is equated to 0. We got two singular points. Actually, what is the center of the circle? 4. I have already given the notes, Amma. Check, tell me. Z minus Z naught is equal to R. Notes dictated, no? Z naught is the center of the circle, R is the radius. You remember that?
Yes, sir. Yes, sir. Yes, sir.
What is the circle equation in our problem? Z minus Z naught is equal to R. Z naught 4, R1. So center 4, radius 1.
R1.
So 4 2,
Yes,
4
sir.
plus 1, 5, 4 minus 1, 3, right?
Yes, sir.
You understand this 3 and 5?
Yes, sir.
Radius 1. Now what are the
Yes, sir.
singular,
I understood. Yes.
both singular points lying outside the closed curve? Apply Cauchy's integral theorem. Applying Cauchy's integral theorem means no need to solve. Directly the value of the integral should be 0. All singular points outside the given closed curve, apply Cauchy's integral theorem. Applying Cauchy's integral theorem means all singular points outside the given closed curve. Understood, Amma? Hello? Next, Amulya. Next, anybody else? Kiran? Kiran?
Audible, sir, now?
Yes, tell me.
Sir, page number 109. I lost the connection, sir.
109, fine.
Question number 5, sir. Sir, here roots are z is equals to plus minus 2 times now.
Same root will be repeated 2 times.
I saw this, but sir, I am getting I divided by pi. So
here z square plus pi square is equal to 0 na. So z square is equal to minus pi square. Minus pi square can be written as pi I whole square. Pi square I square. Pi square I square is minus pi square, right? Z square is equal to pi I whole square. Z is equal to plus or minus pi I.
Right.
So whole square means same set of roots will be repeated
2 times.
Okay, na?
But then we have to use the differentiation formula, sir.
Yes, this model, why you are worrying? This model we need to cover tomorrow.
No, you gave for what's
this is z minus pi whole square into z plus pi I whole square. Then we need to use a differentiation formula only.
I saw that, sir, but I was getting I by pi, so that is why I was.
No. There may be a calculation mistake. Differentiation formula only, calculation mistake.
Okay, sir. Thank you, sir.
Do one thing, check it. If you are unable to get, I'll send the solution.
No, sir, I try for 2 times. The same answer I am getting. I by pi only.
There might be a calculation mistake.
Okay, sir. Okay, sir. Thank you, sir. Thank you.
Next, anybody else? I'm going to end the session.
Hello, sir.
Next, Balajina.
Hello, sir.
Who is this?
Hello.
Who is this? What's your name?
Manideep.
Manideep, tell me.
Sir, page number 104.
Manideep, 104.
Next page, 104. Sir, in this you take 0, 2 outside limits. 2, 0, 0, -2.
Okay. Look here. What is the radius of the circle?
Z equal to 2.
Circle equation Z minus Z naught is equal to R. R is the radius. What is the radius?
2, sir. Radius.
Radius 2.
Yes, sir.
Center 0, no? So from center 2 units right. From center 2 units right. 2 units right. On positive x-axis, y coordinate 0. X coordinate positive. Correct or not?
Okay, sir.
From center 2 units up. On positive y-axis, y coordinate positive, x coordinate 0 on y-axis. Correct or not?
Okay.
For radius 2. From center 2 units left. On x-axis, y coordinate 0, but this point lies on negative x-axis. That's why it is -2. Because radius is 2 now. That's why it is -2, because it is lying on negative x-axis.
Okay, sir. I'm moving that point.
And this is center. This is center to here radius. But this point lies on y-axis. On y-axis, x coordinate 0. But this point lies on negative y-axis. On negative y-axis, y value negative.
Okay, sir. Sir, points lie outside the circle, then it is equal to 0.
All singular points outside the circle, integration value 0.
Sir, 108. Sir, in this, f of 0 means how you calculating 0 plus 1 by 0 minus 2?
This is f of z. Look here. This is f of z. F of z is equal to z square plus 1 by z minus 2.
Yes, sir.
Take f of 0 means in place of z 0. Here z square plus 1 by z minus 2. 0 square plus 1 by 0 minus 2. Got it?
Okay, sir. Next problem. Last dot. Next problem. Fourth, 101, sir. Next page, 111. Sir, in this, why you take z equal to minus in minus of minus I, sir?
See, actually, what is the center of the circle?
0, -1.
No. Circle equation modulus of z minus z naught is equal to r, no?
Yes, sir.
But you are given z plus I. I want to write it as z minus z naught. That is z minus of minus I. Z minus of minus I. So z naught is minus I. Center is minus I. So 0, -1.
Why we are writing z minus of z minus?
Just I want to show what is the center. Center of the circle is minus I. Circle equation modulus of z minus z naught is equal to r. But is it in the form of z minus z naught?
No, sir.
That's why you have to get it in that form.
Okay. Sir, when did anti-clockwise means minus, anti-clockwise is plus means why we taking
direction means negative direction, anti-clockwise direction means positive direction. So
clockwise, why it is negative?
It is conventional. We need to assume that generally we always move like this, reverse order. That is clockwise. Anti-clockwise is negative. Generally, suppose you stand on the curve. How do you move? It is conventional. You will move anti-clockwise only. Generally, we will not rotate like this. Suppose you stand on the curve or a particle on the curve that moves like this, not in the reverse order.
Okay, sir. No, sir. Thank you, sir.
Next. Anybody else attendees? Next, anybody else? Amulya?
Hello, sir. So, sir, actually my connection was disconnected when I asked that time. Sir, in page 91, I have understood what you said that point, sir. So another doubt is we got Uy and Vx as 0, no, sir. They are not, I mean, Uy is not equal to minus Vx, no, sir. But also we have considered that to be a satisfied CR equation. Why, sir?
Uy is equal to minus Vx. Uy 0, minus Vx also 0. Uy 0, Vx 0. Minus into Vx is equal to minus into 0, 0 only, no?
Okay. Yes, sir.
Correct or not?
Yes, sir.
Any other?
No, sir. Thank you.
I'm going to end the session. If anybody is there, please raise hands. Anybody is there, please raise hands. I am going to end the session.